Hi everyone, welcome to today's webinar, Why Invest in a Ci60 series handheld spectrophotometer. Presenting today is Tim Mouw, our Applications Engineering and Technical Support Manager at X-Rite. I'm Robert Grotans, the Global Digital Learning Manager, and I'll be moderating today's webinar.
Thank you, Robert. Welcome everyone, and let's dive right in. We're going to talk about why invest in a Ci60 series handheld spectro, and as the subtitle says, are they worth the upgrade? So let's go ahead and launch into our presentation. So our agenda for today is pretty straightforward. We're going to talk about the benefits of upgrading to a Ci60 series instrument. We will also talk about the differences between the various models in the series, because there are multiple instruments here that we're talking about. We will talk about compatible software solutions that those devices can work with, as well as the training and support resources that are available to you when you purchase or when you own one of these Ci60 series instruments. But to start, let's go back and talk a little bit about legacy devices. And when we're talking about legacy devices, I'm talking specifically about X-Rite handheld sphere-based spectrophotometers. That's what these devices are. That's what the Ci60 series is. And we have 30 plus years of devices that have done that. Going back a long time, 30 plus years, we'd be talking about an instrument that looked like that. It's pretty old, obviously. The models listed there, that was the very first series of handheld sphere devices that X-Rite produced. Those were replaced around the year 2000 or so with the SP60 series, and you can see there are multiple models there, SP60 and 62 and 64. So specifically, those models, the SP60, 62, and 64, are the devices that now are moving. We're moving on and need to be replaced, right? I don't think there's a whole lot of the older ones out there anymore, but if they are, right, all these devices are made to follow, for data to follow and correlate, and so to move to today, right, beyond these legacy devices, we move into the Ci60 series. And in the Ci60 series of devices, we have actually four different models. I'm going to just show you several pictures. So we have a device called a Ci60. We have a device called a Ci62. And we have a device called the Ci64, and there is also a Ci64 with a UV for ultraviolet behind its name. And we'll get into how those devices differ, you know, what do I get with one versus the other in a little bit. But before we do that, before we talk about the difference between the models, we want to talk about the whole benefits of upgrading. So what do I get with the new instruments that I didn't have with the older ones? What do the new devices bring to the table? Well, first off, and I kind of alluded to this earlier, we have legacy data compatibility. That's really important. If you've got color standards that you measured with one of those legacy devices, and you want to be able to use those standards or use those any measurements you did with the older devices and now use a newer device, we need the data to be compatible, meaning they read the same. And the device agreement between the new instruments, the Ci60 series, and the older SP60 series is within what we call inter-instrument agreement specifications. So those are big fancy words. Let me make it more down to earth real here. As an example, an SP64, and we are of course here assuming all the instruments are in good, proper working order, they've been maintained properly and so on, right? Nothing's contaminated or anything. But if we have good working instruments, an SP64 to a Ci64, the agreement between those devices is exactly the same as the agreement would be between two Ci64 agreement instruments or two SP64 instruments. So the reality is they measure the same, right? They agree across the models as well as they agree within the models. So we have data compatibility. That's a big deal because it means you can continue to use data you have today. Second thing is that with the Ci60 series, we have the ability to embed Net Profiler. And what we're talking about, Net Profiler is a piece of software that allows you to profile your instrument, to let the software make minor adjustments to the device based on the environment you're using it in, right? To correlate your instrument, it's kind of an extension of calibration if you want to think of it that way, right? Bring your device back to reading like it did when it was new, right? Net Profiler allows you to do that. You could net profile an SP64, but the problem was the profile could only be active when your measurements came into software on a computer. That's when the profile would get applied. And so if you took a measurement with an SP64 and you had a profile applied, your LAB numbers in your software might be different than your LAB numbers on the screen of the device because the device had no way to apply the profile. So we could only apply the profile post-measurement, so to speak. On a Ci64 or a Ci60 series device, right, the profile can be embedded on the device and it'll actually show you on the device screen if it's got a profile, if it's using a profile or not. That means when you go take measurements remotely, your instrument gives you exactly the same results as if you were taking them connected to the computer with a profile applied. So it allows you to use the profile on all the measurements, not just the ones when you're connected to the computer. There are no battery limitations. Might seem silly, but all of the previous versions of the device, right, the SP60 and even prior versions, the instrument, even when it was plugged into the charger, had to have a battery that was functioning and had some charge to it because it needed that in order to fire the lamp and do all of that. We no longer have that limitation. The Ci60 series can run without a battery. You simply plug it into the charger, it'll run directly off of the current coming from the charger. That's nice if you happen to have a battery that dies. It doesn't mean you have to get the battery charged before you can start taking measurements. No more RS-232 and adapters, right? The SP series were all RS-232 serial port, which meant lots of having to use USB to serial adapters and those kinds of things. Today, the Ci60 series is full USB and Bluetooth communication possibilities. We've got online e-learning courses in up to 10 languages on device use and the basics of the software. And then the service and support, right? That continues for the Ci60 series as long as we sell them in and beyond, of course. But service and support ends for the SP 60, 62, 64, that series on December 30 of this year. Because those devices will have been out of production for a full 8 years at that point. So keeping current obviously means all of that comes to you. So those are the benefits over the previous devices. Now let's look a little bit at the difference between the different models. And so you'll see across the top, we've got a Ci60, a Ci62, a Ci64, and a Ci64 UV. And we're going to look at a number of rows of information. And if we look at this from left to right, you'll see in bold text and highlighted in green if there's something that the model on the right does that the model to its left couldn't do. So for example, Ci60, it only has one aperture size, right? Which is an 8mm measurement area, and the target window, meaning the opening in the window for where you put the sample, is actually 14mm, because of course we can't measure right to the edge of the window. So it's one aperture size for a Ci60. For a Ci62, we can have a 4mm or an 8mm or a 14mm, but you got to pick which one you want, and it's fixed, and that's the only aperture size that one can use. But you've got 3 options with a Ci62. When we go to the Ci64, we now have either a switchable, meaning that one device can be either 4 or it can be 4 and 8, not like at the same time, obviously. There's a switch, and you actually change the target window. So you can switch between a 4mm and an 8mm, or you can get the large aperture. But if it's the large one, it's fixed as a large aperture. You can't switch anymore. Okay, Ci64 UV only has the 4 and 8 switchable. It does not have the large aperture available. So that's the measurement sizes. Short-term repeatability talks a bit about how well does that instrument repeat measurements. These are done on the white ceramic calibration tile, right? There's a series of measurements you do, 30 to 50 measurements, timed measurements, one every 10 seconds or something like that, and then calculate how much, essentially we're measuring how much noise is there in the instrument. So Ci60 is 0.1 delta E across that white ceramic tile or less, right? The spec is 0.1, so it needs to be that or less. With the Ci62, it drops to 0.05, and for the Ci64 models, it's 0.04. Okay, short-term repeatability, not a big issue. Inter-instrument agreement, now we're talking about how well do two models agree with each other. These are tests done using BCRA tiles, 12 different colored tiles. Every instrument we manufacture and when we service a device, right, gets tested on those tiles to make sure it falls within this tolerance. So a Ci60 is average 0.40 delta E across those tiles. With a Ci62, that gets cut in half to 0.2 delta E across those 12 tiles. And then the Ci64 models fall even further, right, down to 0.13. Now, as you may have assumed or guessed, as you go from left to right in this graph or this table, right, you're improving and increasing performance. You are, of course, also increasing costs because you're making a more precise, accurate instrument with more features and functions. But this is helping us outline and understand which device might be the right device for what you need to do. Modes and functions. So these are things the instrument can do if I'm using the instrument all by itself. If I weren't going to connect it, right? These are all things I can do in the device using the on-screen or on the device screen and controls. So the Ci60 does quality QA, which is basically store a standard, measure some trials against it, right? Compare, which is just a quick, I want to compare measurement 1 to measurement 2 to each other, right? Opacity and strength. The Ci62 adds something called projects, which is a way of organizing standards. So I could use that project mode, for example, to have a group of standards together that are the standards that maybe these are the colors I'm going to measure today, and I put them in a project. Then I can use the device to go take measurements, and when I measure a sample or a trial, it'll automatically use whichever standard within that project is closest to the color I measured. So I can do some auto selection things and so forth with projects. Move to the Ci64 units, and we add this thing called a jobs function, which is something that we can use with software where we're able to download from the instrument a job, and a job is more than just color standards. It might actually be instructions to the user on screen in the device, telling them where specifically to measure. Perhaps I'm measuring something that's fairly large and I need to measure in multiple places. It can actually prompt them through measure here, now measure there, now measure there, and it's capturing and that data, applying some metadata and tags to it and so forth. That's what a job allows us to do. And then the Ci64 UV, of course, as its name might indicate, it has UV calibration in it. What's UV calibration good for? Anyone who's measuring something that is optically brightened, whether it's fabric or paper, right? Has an OBA, an optical brightening agent in it, a chemical that's put in to make a white whiter. In order to measure and QC the effect of optically brightened things, you need to be able to calibrate the UV component within the instrument, which is of course related to the light source within the instrument. So the Ci64 UV has the ability to do UV calibrated measurements, so we can properly characterize those optically brightened samples. And then finally, software connectivity. So the Ci60 connects to one thing only, and that's just a configuration tool. So it will not, it is basically, other than the config tool, it's a standalone device. You can't profile and use Net Profiler with it. You can't hook it up to a computer and save your measurements. It's all just living on the instrument kind of measurement. When we go to the Ci62, we now introduce for it and the Ci64 models, the ability to use Net Profiler, as I discussed earlier, right? To use QC and formulation software, right? It gets used with IQC or iMatch software for people who are doing paints and plastics and textiles. It also gets used with ColorCert and IFS, ColorCert being a quality control software, IFS, which stands for ink formulation software, in the print world. So these devices get used in many different industries, and we've got software, whether it's QC or formulation software, that they connect to. And so, of course, there's much more information in detail you can get to on our website about each of these models, but these are kind of the key things of what differentiates them. Helps me be able to say, okay, if I know I need to be able to, obviously, if I need to be able to measure optical brighteners, it's a pretty easy decision about which instrument is right. But if I'm doing QC and I want, I need a large aperture and I need to be able to profile it and stuff, okay, maybe it's a 62, maybe it's a 64, right? If I know I need to be able to measure multiple sizes, then I'm going to have to go to the 64. If I only need one aperture and I can live with that, maybe it's the Ci62. Those kinds, the things in here, I think help determine which is the right model for you, depending on your workflow. All right, so let's talk a little bit more about the software solutions, just to give you an input on that. So the Ci6x config tool, it's a piece of software. It looks like that. This was grabbed yesterday or the day before with my instrument hooked up to my Ci6x config, and you can see it tells me the model and the serial number and the firmware version, and in bright green says it's connected. All those tabs, the lower row of tabs, general, system setup, color setup, each of those tabs is getting me to another section of the configuration of the device. Now, I could do all of those things in those tabs, the lower row of tabs, on the device itself. But of course, doing them on a little screen on a device and having to move back and forth can be a bit laborious. If I have lots of settings I want to change, I have the ability then to do them here through the software, where it's much easier to do that. You'll see on the right-hand side there, it says show setting on device. I can even turn off options because maybe I don't want my users who are using the device to be able to go in and change things on the device. The other thing that's really nice about this is once I get it all set up, for example, in color setup, I'm going to set up what illuminant observer am I going to be using as my default, right? And maybe you only ever care about one, so you want to turn the others off so somebody doesn't accidentally get to the wrong ones. But once I get everything set here, I can then go up to the tab on the top where it says backup and restore. I can back up all the settings I just made on this device. And the beauty of this tool is if I have another device, I can plug that device in and I can restore the settings file I just created to that device. So if I have multiple devices that I need to set up in one fashion so that they all work the same, maybe I've got 4 devices through my plant, I go through this process once, set it all up, then I can just restore it to each device. Now all the devices are configured identically and I'm ready to go use them. The one other cool thing this does is this thing called remote control, which literally, this is just a screen grab I threw out there, right? Shows this screen of the device. And if I do that when it's connected, if I'm using my instrument, if I'm hitting the buttons on the instrument, the display here is actually going to change. And it's a very nice tool for if you need to train users, right? Because it's hard to get everybody in front of an instrument. The screen on that device is maybe 3 to 4 inches by, 2 by 3, 3 by 4, something like that, right? It's hard to get a bunch of people around seeing what's going on. It's very easy if you do it like this, because of course you could put it on a projector or a big screen or whatever and show people how you're using it and things like that. And you can see on this device, it's showing me that it's ready to measure a sample, right? That it's showing me absolute LAB, delta LAB, what conditions it's in. The little yellow here means that my net profiler is not enabled right now, right? Is it connected? It's connected USB, and so on. So the instrument's telling me all that. This config tool works great to help me with all of that. Then Net Profiler. So Net Profiler is a piece of software. Looks kind of like that when you launch it. Again, hooked up my device to it, right? And I would be ready to go ahead and profile. And what profile involves is this. These are, it's hard to see, but each one of these little circle pieces is a tile, has a tile in it of different colors. There's a white, a couple of grays, a red, a green, a yellow, a blue, and orange. And those tiles we have known values for because these are serialized. And so you would go through and the process of measuring them tiles with the device. They're shaped like this because they actually fit into a holder that looks like the calibration stand, so we can go ahead and profile the device. And when we're done, the profile gets stored to the instrument and away we go, and we know we are measuring accurately. QC software, I mentioned, and these are just quick screen grabs. This is Color IQC, right? You can see I've got a color standard with a whole bunch of samples against it with delta values and plots and even sample swatches of the color. I can also do QC measurement in ColorCert if I'm in the world of ink, where I'm measuring ink on a substrate. And then we've also got formulation software where I'm now not just measuring a color standard, but I'm even generating a formula, right? This happens to be for a plastic, ABS plastic. It's telling me what percentage or how much of each of these colorants I need to mix together in my plastic in order to manufacture or match that color. IFS similar, right? I got a color standard and it's going to generate a formula for how I would formulate that. So these devices work with those software solutions in what we would call a full solution or an ecosystem to be able to enable you to do what you need to do, whether it's QC formulation and so on. Last section here is about training and support resources. First of all, interactive e-learning. X-Rite has a Color Services interactive e-learning site that has a number of courses on it. Some of them are free, some of them are paid for, but I'm going to show you this because in the industrial color and QA area of the training, you'll see there's a Ci6x training that's a free course. There's an IQC training that's a free course. There's a Net Profiler that's a free course. Now, if you want to learn about the fundamentals of color and appearance and the science behind the numbers and all that, we have a course about that as well. That's a chargeable thing, but anyone who buys a Ci6x is going to automatically get this training. And the way these courses work is they are a series of videos. You go through the videos. It's someone literally running a device. You can have them, teach you how to show you how to do something, pause the video, go on your instrument, do it yourself. It's a great learning tool and can be somewhat interactive. We have similar courses in the press room and ink world for other Exact, that's another instrument we sell, right? ColorCert, ink formulation, right? There are free courses there for those things. And one of the really nice parts about all of these courses is when you finish one, you're going to take a test, and when you're done, there's a copy of my certificate, right? That means I took the course, I passed the test at the end. I can even say, hey, I've got my operators certified that they've passed the test on how this particular product works. So I know that they have the basic training done. So in addition to interactive e-learning, of course, we have support, and that's our website, right? So For each of the model instruments, you'd be able to find a page, right, where you can view product details, you can request service, you can register your product. You even have a contact us button up at the top if you need to reach out and ask for some technical assistance. Underneath this, you'd find things like downloads of the software that the instrument connects to, the configuration tool, firmware, if we need to update the firmware of a device. There are support articles, user guides, manuals, and so on. So all of that is available to you on our website. It's available for you to go look at right now if you want. Sometimes that's good information to see as you're considering, if you're considering upgrading your instrument to get more information about the new device. So that takes us through our agenda, and we get to a point where we have questions, or we're ready to answer some questions. And Robert, I think you had something you wanted to interject here as well.
Yep. So if you have any questions, please feel free to submit those now if you haven't already. While we wait for questions to come in, I am going to launch a poll question. If you would like to talk to a sales representative or learn more, please feel free to answer this quick polling question, and then I will turn it over to Tim to filter through any questions that might come in.
Thanks, Robert. So one question we have is a question about specular included and specular excluded. So without going into too much in-depth detail about what those things are, right? Two modes to measure with a sphere-based instrument. And the reason that these instruments are called sphere-based, if you have one, whether it's new or old, if you look inside the aperture, you'll see inside it's a hollow white sphere. Specular included essentially means measure all the light that reflects off of the surface, including, hence included, including the light that reflects because of the glossiness of the surface. Specular excluded means measure all the light that reflects off the surface except or excluding the light that's reflecting because of how glossy or non-glossy the surface is. That gives us two ways to measure, right? To see, is my gloss affecting my color or not? And the beauty of these handheld devices, the X-Rite handheld devices, is we measure them simultaneously. So with every measurement you take, you get both specular included and specular excluded results. And so you don't have to worry about which way did I calibrate it, which way do I want to save my measurements. No, we're doing both simultaneously, consistently all the time. And so that's a real advantage, right? Because the last thing you want to do is have a measurement and then have to go back and calibrate and switch. And X-Rite's been doing simultaneous spin specs with our handhelds from the inception of them, and it's something that's unique to us. There are others who can do it now, but that's a real advantage for you to be able to get both simultaneously and have both sets of data. All right. Other question was about downloading, uploading and downloading, what we mean by that. So with a handheld instrument, I can of course create a color standard with just the device, right? I've got you know, a keypad and interaction with the interface and so forth, where I could measure something, I could scroll through and type and put in a name for it. I can enter a tolerance, all those things, and I could save it on the device. Okay, and then I could compare samples to it. So I could do all that on the device by itself. Likewise, if I'm hooked up to one of those pieces of software, I could be creating my color standards, names, tolerances, all those things in the software. So when we say upload or download, okay, download means send from what I'm working in, software, down to the instrument. So I could send the color standards down to the instrument, and then I could go, let's say I know I'm gonna manufacture these 4 colors today. I download those 4 colors, hand the instrument off into the production environment, and they're doing their measurements wherever I need them to throughout the day. At the end of the day, they can come back, plug the device in, and upload, send the measurements back from the instrument up to the software, and then they're in the software just as though I'd measured them while I was connected. But the other thing I can do is that standard I mentioned at the beginning that I created in the device. When I go to upload, if my software sees, hey, there's a measurement in your instrument that's not in the software, do you want me to upload that too? Maybe I do. Now I get the standard and the samples. And so we have the ability to use it remotely, not use it remotely. And it can be tethered, where essentially it's plugged in all the time and I'm just using it connected to the software. It can be used entirely standalone, remote, all by itself, and you can use it in any kind of a hybrid fashion you want. Last question I've got, and then we'll end is storage. So handheld instrument stores up to 1,000 standards and 4,000 samples. So it will store a lot of data. Your battery, a single charge on a battery won't last long enough to take that many measurements, of course. You'll have to be charging it or swapping batteries or whatever, but it does have the ability to do that many measurements.
Perfect. Thank you, Tim. Just to jump in quickly, this will mark the end of our webinar. If you do have any questions that we didn't get to, we will be sure to follow up with you. You will also receive an email after this webinar with a link to the recording. So again, thanks everyone for joining us today and have a great rest of your day.